composition of Arrhenius theory. Let you take a simple reaction. That reaction is between H2 and I2. Product is 2HI. Okay, how activated complex is formed and the energy is known as activation energy. That can be explained by this reaction. This H2 means there is a bond between hydrogen and hydrogen, plus I2 means a bond between iodine and iodine. These are two reactants. They are undergoing effective collisions. If they undergo effective collisions, they must be having some minimum energy as well. If they are reaching or forming activated complex, minimum extra energy is also there. Now, if they undergo effective collisions, there is a formation of this type of reacting species, that means called as intermediate. This is meaning as there is slowly breaking of bond between hydrogen and hydrogen, breaking of bond between iodine and iodine, formation of bond between hydrogen and iodine. Okay, ಈಗ ಇದೇನಾಗ್ಲತ್ತೈತಿ ಅಂತಂದ್ರೆ ವೆರಿ ಶಾರ್ಟ್ ಟೈಮ್ ಅಪಿಯರ್ ಆಗ್ತೈತಿ. Breaking of hydrogen iodine bonds and formation of hydrogen iodine bonds, immediately forming the product. That product is called as hydrogen iodide, Hi plus Hi, or you have to represent it to Hi. So this type of complex is called as activated complex, or it is also known as intermediate. It appears in the reaction mixture very shortly and decomposes, forming the stable product. Now I will explain or take with the help of a graph. That graph is taken as along x-axis reaction coordinate and along x-axis reaction coordinates and y-axis potential energy. I will take the reactant H2I2. Generally I will take it as A. H2I2 reactant ಗಳಿಗೆ A ಅಂತ ತಗೋತೀನಿ. If they undergo effective collisions, definitely they are forming activated complex. This point is said to be unstable, highly unstable point. Definitely there is a breaking of bonds forming the product. That product is called as 2HI. Product is B. Unstable state is intermediate or activated complex. Between this reactant and the intermediate, the energy needed by reacting species to reach this point, to need this activated complex ಅನ್ನ ರೀಚ್ ಮಾಡಲಿಕ್ಕೆ ಬೇಕಾಗಿರತಕ್ಕಂತ ಎನರ್ಜಿ, ಅದಕ್ಕೆ ಏನಂತ ಕರಿತೀವಿ, ಆಕ್ಟಿವೇಶನ್ ಎನರ್ಜಿ. ಯಾವಾಗ ರಿಯಾಕ್ಟೆಂಟ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ಗಳು activated complex ಅನ್ನ reach ಆಗ್ತಾವ, definitely they are forming the products. So this energy is called as activation energy. During the conversion of reactant to product, if product value is greater than reactant, hence always you can say that heat is released. That reaction is called as exothermic reaction. Suppose endothermic ಇತ್ತು ಅಂತಂದ್ರೆ ಗ್ರಾಫ್ ಹೆಂಗಾಗ್ತೈತಿ, ಈ reaction ಇನ್ನೊಂದು ಸ್ವಲ್ಪ ಅಬ್ಸರ್ವ್ ಮಾಡ್ರಿ. A is nothing but reactant. Reactants are H2 plus I2. They are undergoing effective collisions, forming transition state, activated complex, intermediate. ಇದನ್ನ ರೀಚ್ ಮಾಡಲಿಕ್ಕೆ ಬೇಕಾಗಿರತಕ್ಕಂತ ಎನರ್ಜಿ ಏನಂತ ಕರಿತೀವಿ, the amount of energy required to form activated complex, called as activation energy. Okay, once this stage is formed, definitely they are forming the product. ರಿಯಾಕ್ಟೆಂಟ್ ಇಂದ ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮ್ ಆಗ್ಲತ್ತಿತ್ತು ಅಂತಂದ್ರೆ ಇಲ್ಲೇನಾಗ್ಲತ್ತೈತಿ, ಈ ಟೈಪ್ ಇತ್ತು ಗ್ರಾಫ್ ಅಂತಂದ್ರೆ ಇದು ಕಡಿಮೆ ಇದು ಹೆಚ್ಚಿತ್ತು ಅಂತಂದ್ರೆ ಇಲ್ಲಿ ಎನರ್ಜಿ ರಿಲೀಸ್ ಆಗ್ತಿರ್ತೈತಿ. ಸಪೋಸ್ ಅದನ್ನ ಬಿಟ್ಟು ಇದಕ್ಕೆ ಎಕ್ಸೋಥರ್ಮಿಕ್ ರಿಯಾಕ್ಷನ್ ಅಂತ ಕರಿತೀವಿ. ಡೆಲ್ಟಾ H is equals to some amount of heat is released, that is exothermic reaction. ಅದನ್ನ ಬಿಟ್ಟು ಸಪೋಸ್ ನಮ್ಗೆ ಎಂಡೋಥರ್ಮಿಕ್ ರಿಯಾಕ್ಷನ್ ಇತ್ತು ಅಂತಂದ್ರೆ ಈ ಕೇಸ್ ಹೆಂಗಾಗ್ತೈತಿ ಗ್ರಾಫ್, that graph is, I will take here the reactants are giving the product P. Here what happens, delta H is said to be reactant and product ಇದ್ರಾಗ ಬಂದಾಗ ಏನಾಗ್ತೈತಿ ರಿಯಾಕ್ಟೆಂಟ್ ಎನರ್ಜಿ ಇಸ್ ಮೋರ್ ದ್ಯಾನ್ ಪ್ರಾಡಕ್ಟ್ ದೇರ್ಫೋರ್ ಇಟ್ ಈಸ್ ಪಾಸಿಟಿವ್ ಅಂತ ಕರಿತೀವಿ. ಈ ಟೈಪ್ ಆಫ್ ಗ್ರಾಫ್ ಇಲ್ಲಿ ರಿಯಾಕ್ಟೆಂಟ್ ಇರ್ತೈತಿ, ಇಲ್ಲಿ ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮ್ ಆಯಿತು, ಇದು ಆಕ್ಟಿವೇಟೆಡ್ ಕಾಂಪ್ಲೆಕ್ಸ್. ದ ಡಿಫರೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದಿಸ್ ಪ್ರಾಡಕ್ಟ್ ಆ್ಯಂಡ್ ರಿಯಾಕ್ಟೆಂಟ್ ಡೆಲ್ಟಾ ಎಚ್ ಈಸ್ ಪಾಸಿಟಿವ್. ಇದು ಎಂಡೋಥರ್ಮಿಕ್ ರಿಯಾಕ್ಷನ್. ಓಕೆ, and one more graph I have drawn here. That graph is said to be the remaining number of molecules. ಕೆಲವೊಂದು ನಂಬರ್ಸ್ಗಳಿಗೆ ಏನಾದಂತಂದ್ರೆ ಕೊಲೈಡ್ ಆಗಿ ಇಫೆಕ್ಟಿವ್ ಕೊಲಿಷನ್ ಆಗಿ ನಿಮ್ಮ ಪ್ರಾಡಕ್ಟ್ ಫಾರ್ಮ್ ಆಯಿತು. ಎಲ್ಲವೂ ನಿಮಗೆ ಒಂದೇ ಸಲಕ್ಕೆ ಅದನ್ನು ಎಫೆಕ್ಟಿವ್ ಕೊಲಿಷನ್ ಆಗಿಲ್ಲ. ಒಂದಿಷ್ಟು ಮತ್ತು ಮಾಲಿಕ್ಯೂಲ್ಸ್ಗಳು ರಿಯಾಕ್ಷನ್ ಉಳ್ಕೊಂಡು ದೋಸ್ ರಿಮೈನಿಂಗ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ದೇ ಆರ್ ಸೇಡ್ ಟು ಬಿ fraction of molecules. They are called as fraction of molecules. Those fraction of molecules I will represent symbol as Ne divided by Nt. That means total number of molecules. Total number of molecules naga there are some number of molecules that are having some kinetic energy. That kinetic energy is called I as most probable kinetic energy. ಇಲ್ಲಿ ಗ್ರಾಫ್ ಏನು represent ಮಾಡತೈತಿ? Maximum reactants are converted into product. That means this area is called as most probable kinetic energy. ಒಂದೇ ಪಾಯಿಂಟ್ ಅಂತ ಬಂದಿಲ್ಲ, ಇಲ್ಲಿ ಒಂದಿಷ್ಟು ಮಾಲಿಕ್ಯೂಲ್ಸ್ಗಳು ಈ ಪಾಯಿಂಟ್ ಅನ್ನು ರೀಚ್ ಆಗಲಿಕ್ಕೆ ನೋಡತ್ತವು. ಅದಕ್ಕೆ ಈ ಪಾಯಿಂಟ್ ರೀಚ್ ಆಗ್ತಕ್ಕಂಥದ್ದು ಏನಂತ ಕರಿತೀವಿ ನಾವು? ದ ರಿಮೈನಿಂಗ್ ಫ್ರಾಕ್ಷನ್ ಆಫ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಆಲ್ ಟುಗೆದರ್ ದೇ ಆರ್ ಕನ್ವರ್ಟಿಂಗ್ ಇಂಟು ಪ್ರಾಡಕ್ಟ್ ವೆನ್ ದೇ ಆರ್ ಅಕ್ವೈರಿಂಗ್ some extra kinetic energy. Okay, so this is called as most probable kinetic energy. Most probable kinetic energy means maximum number of the kinetic energy possessed by maximum number of fraction of molecules. ಏನು ರಿಮೈನಿಂಗ್ ರಿಯಾಕ್ಷನ್ ಮಿಕ್ಸ್ಚರ್ನ ರಿಯಾಕ್ಟೆಂಟ್ಸ್ ಅದಾವಲ್ಲ, ಆ ರಿಯಾಕ್ಟೆಂಟ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ಗಳು ಎಲ್ಲವೂ ಏನು ಮಾಡತ್ತಾವು? ಪ್ರಾಡಕ್ಟ್ ಆಗಲಿಕ್ಕೆ ನೋಡತ್ತಾವು. ಅದಕ್ಕೆ ನಾವೇನು ಕರಿತೀವಿ? Most probable kinetic energy possessed by the fraction of reacting species or fraction of molecules. Okay. Now, one more point is very important. How temperature is dependence on rate of reaction. Time notice. Temperature dependence graph. Temperature dependence just agati graph. I will draw here that graph as fraction of molecules and reaction to kinetic energy. Fraction of molecules I will take as Ne divided by Nt. Ne divided by Nt. And this is kinetic energy. Suppose a reactant I have used here, that reactant is converted into product at the time T. Reactant is converted into product at the time T. This is at the time T. Okay. Now, the same reactants are converted into product at the time T plus 10 degree. At the time T plus 10 degree. Just to observe in this case, the area covered by product area covered by the reacting species in order to form product at T degree is only this much area they have covered, but at T plus 10 degree they have covered double than the temperature T. Indicates that for every 10 degree rise in temperature, every 10 degree rise in temperature, rate nearly doubles, or sometimes it is said to be 3 times, 2 times or 3 times. ಇಂಥ ಕೇಸಸ್ನಲ್ಲಿ ಏನಾಗ್ತೈತೆ ಅಂತಂದ್ರೆ ದ ಫ್ರ್ಯಾಕ್ಷನ್ ಆಫ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ದೇ ಆರ್ ಅಕ್ವೈರಿಂಗ್ ಮ್ಯಾಕ್ಸಿಮಮ್ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ. If they are acquiring maximum kinetic energy, the activation energy of those are said to be more. Definitely they are reaching the product formation. So this is one of the important questions you have to consider. What is the effect of temperature on rate of a reaction? Represent graphically. If you use one curve at a T temperature, that area covered is small, whereas at T plus 10 degree the area covered is said to be doubled. When the fraction of molecules they are needed extra 10 degree, definitely rate is said to be doubled. Okay, so this is about temperature dependence graph. Now in the similar way, I will give one important equation. That equation is of Arrhenius form. That equation is K is equals to A into e raised to minus Ek divided by RT. ಇದು ಒಂದು ಫಾರ್ಮ್ Arrhenius equation. Now I will take natural logarithm on both sides of this equation. That is ln K is equals to, or you have to take natural log on both sides. Ln K is equals to minus Ea divided by RT into ln K. Ln K is equals to minus Ea divided by RT plus ln A. So this is second type of equation. You can take at two different times, K1 and K2 and temperature T1 and T2. I will represent this second equation at two different rate constant and two different temperatures in the next class. Okay.